While I don't think that macros are conceptually the most difficult concept in this course, I do think they are the weirdest in the sense that so far we've been used to writing functions that produce some output, and usually that output looks like a number or a list. But now we are writing code that will produce as output not a number or a list, but actually more code. And that is very weird, and we're gonna have to get used to it. But throughout this video, I'm gonna be sort of reorienting ourselves back onto that central motivation or that central big picture that we're writing code to produce code. And it's going to help us keep our heads straight. And as long as we do that, we're going to be able to understand code very well. So um, again, I'm going to spend a lot of time motivating macros because this concept is so strange. The whole story starts with programs as data, and macros are really just a way to implement programs as data. So let's understand that first, and let's start in Python. So here is a program in Python. Here's some code that we can run, and here are some data types that we know for Python. We have numbers, we have strings, we have lists, and so on. The question is, can we write our program as a form of data? That's the big picture. Can we use the elements of our language, being the data, to produce executable code, to produce programs that we can run? So we can. And so in Python, I asked you, what data type is serviceable for running our code, right? So up here, I have some code I want to run. Uh, what data form can help us capture and store that code so that it can be run later on? It will actually be the string. And Python give us some convenient functions so that I can take my executable code right here, stick it in a string, and then we have these very useful functions, eval and exec, that when I call eval on a string containing code, it would actually run the code. So very sort of strange paradigm, but it is, it does exist. This is out of scope, but eval will evaluate a string expression while evaluates or executes a string statement, right? A statement being some form of assignment or define. Um, so yeah, okay. I mean, that's pretty cool. We've squared too. Can we do something more interesting, right? Can we make our programs as data dynamic? Can we pass in arguments? And so let's do that. Let's write a function that can actually take in a parameter and output some data that can then be executed as code, right? Let's make our data customizable. And so let's do that. I'm going to call square as data on two. And then my data is now x squared. Cool. So let's try to eval our new code, and I'm going to get a name error. X is not defined, and that makes sense, right? So when someone calls my function, I try to return x asterisk asterisk two. And then when someone tries to eval this, how exactly is Python smart enough to know that, oh, hey, they want the parameter x in this as opposed to just the string x, or the character x, right? Python isn't smart enough to know that. And the way we can get it to actually produce that behavior is using f strings. So with an f string, we can instruct Python that, hey, when you see something in a curly brace, I don't want you to actually use the physical letter x. I want you to look for the value of x in the current environment. And x is 2, so we're going to plug this 2 into the string, giving us sort of a dynamic string. And f string is super useful, very important to know in Python. So yeah, let's use that in here. And now I can return a sort of dynamic string that can actually take as input the parameter x. So now it's going to work out. Call square as data on 2. My data, see now instead of saying x squared, it's going to say 2 squared. And if I eval this, I get my 4. So guess what? We've just done programs as data in Python. Not sure if you knew we could, but I did wanted to start there just as so we let's start somewhere familiar before we jump into something more foreign. So programs as data in Scheme is actually the exact same as what we just did in Python. So let's say I want to execute some code, 2 squared. And in Python, that data type happened to be a string. But what's going to be the equivalent, the analog in Scheme? Well, in Scheme, we know that the language is constructed in a way so that we have our basic atomic types, such as numbers, but then everything else is a combination of things, right? So and by that I mean that everything is simply a list of our atomic types, like numbers and functions, right? So scheme was designed such that all combinations are internally represented as lists. Okay? So internally, there's no distinction between what we think of as a list, um, like a list that looks like this, and an expression that looks like this, right? All of our expressions, all of our call expressions are really just lists. They look like lists, and that's exactly what they are. So what this means is that while in Python, our code are sort of represented internally as characters, as strings, in Scheme, all of our code is represented internally in the form of lists, and that means that the data type that we'll use to write our programs in is going to be the list. Okay, so let's summarize that. If I want to do programs with data in Python, I'm going to write my program being 2 squared as a string, my data type of choice. It just happens to work out that way. In Scheme, it just happens to be that the data type of choice is now going to be the list. And all of the programs that I want to write, I'm now going to capture them as a list. So instead of writing a function that returns a string, I'm just going to write a function that returns a list. And you guys all know how to build lists. We've been learning since the first week of Scheme, right? So we've reduced our problem from like complicated programs of data to just making a list. Can you make a list with asterisk x x? And you sure know how. You just cons and asterisks onto cons of x onto cons of x, and you are done. Okay? So obviously it's a little uglier than what we had in Python, where I can just use an f string and be done. But conceptually, it's the same idea. Okay? So now, observe left to right is the same thing, okay? So I have my function, and when I call it, it returns my program stored as data. And then when I evaluate that data, I get the actual value, okay? So do you see sort of what I was touching on in the intro? Like I'm no longer writing a function to compute a value, a number, or a list. I'm writing a function that or I'm writing code that produces more code that can be evaluated to the actual value that I want. Yeah, programs as data, we have reduced it down to a list construction problem. So we better be good at building lists. In Scheme, we can build lists once again using cons, this is like the link constructor in Python. We have the list function, which is just like the list brackets in Python. And then, and then we have quasi quote, which we can think of as f strings. Um, so the big idea here, or this is a syntactical shortcut, right? Quote and then parentheses instruct Scheme to make a list. And then the big idea here is that columns and lists are both sort of procedures. And when you call a procedure, the operands are going to get evaluated, right? So because of that inherent behavior of the language in which all the operands get evaluated, it must be the case that I have to quote what we don't want to evaluate, right? So Scheme is automatically trying to evaluate everything. So I have to add in quotes to tell it, hey, no, don't touch this. If you try to evaluate it, you're going to error because you're not going to recognize what an asterisk is. So we have to add in a quote here to tell it to not evaluate it. Whereas with a quasi quote, everything is evaluated. So now I have to tell Scheme like, no, like this thing I actually want to evaluate. And to give it that instruction, we're going to add commas. And commas have to work in conjunction with the quasi quote, and they counteract each other. Observe the opposite thingy here, right? So with cons and lists, you have to quote what we don't want to evaluate. With quasi quote, I have to unquote what we want to evaluate. Cool. So yeah, quasi-quo is the same idea as f strings. Okay, so we are ready for macros. Let's see what Google says a macro is. A macro is a single instruction that expands automatically into a set of instructions to perform a particular task. Um, pretty solid definition, right? That single instruction is like our data, and then when we evaluate our data, it's going to expand out into a set of instructions, the code that will actually produce our behavior. So isn't that what we've been doing so far, right? When we wrote those functions to produce more code, we were doing, we were sort of writing macros, but it was pretty clunky because I wrote this function and then that function produces more code. And then I had to hit that code with an extra eval to actually get the value I want. So, just a little bit annoying. It's a bit kind of annoying that after we define a procedure, we have to evaluate it before we can use it. And so today we introduce the define macro special form, which is going to help us which is going to help us implement programs as data. Macros are specifically there to help us achieve programs as data. And this is not something that's very common in other languages, which is why this topic is very hard and very strange. But it's hard because it is so strange. And then hopefully I will convince you that, we can all be good at writing macros. So, okay, so here's just sort of like the textbook definitions, the important theory that you need to know. Let's compare and contrast a normal procedure and a macro procedure, and specifically how each of them get evaluated under the hood. So here I'm going to define sort of the fake macros that we've been writing so far, where you have to evaluate them, right? We're writing a function that returns more code, and when you evaluate that code, you get your output. And this is the same procedure that we've learned on the first week of class. I'm not going to read this to you, but we just evaluate the operator, then the operand, and then apply. So I'm going to now write a macro. I'm going to copy and paste this code over here, but instead of define, I'm going to do define macro. So let's see how that just changes everything. So now we're still going to evaluate the operator, but now it's going to come out to a macro procedure. And then we already see a difference. I'm going to apply the procedure onto the unevaluated operands. I'm not going to evaluate the operands. And then finally, I'm going to evaluate the body. And then after returning it, I'm going to hit the value you produce with an extra evaluation from the frame it was called in. Okay. And that's what's going to let us skip this annoying step where I have to eval it on my own. Okay. So let's see what this looks like. Okay, so on the left, I called f of 2 and I produced this code. On the right, I'm going to call f of 2. What happens? Okay, so this 2 is going to come into my function. Step 2 says that my operands are not evaluated. And what does unevaluation mean? Unevaluating means adding a quote. Those are direct analogs because a quote guards from evaluation. So it feels very weird when I say this, but every single operand that enters a macro procedure is going to gain a quote. Okay, so it now has gained a quote. It's going to keep flowing into the function. Just like a normal procedure, I'm going to evaluate the body of the expression and then return it, right? So I'm going to evaluate this. Scheme sees the quote in the parentheses, so it's like, okay, they want me to make a list. So I'm going to start making a list. Okay, they want to put an asterisk in the list. They want to put, oh, what is this thing? Comma quote two. Anytime so comma tells me to evaluate, quote tells me to unevaluate, so they kind of cancel out, and I'm just left with the two. So we're going to stick the two in there, we're going to stick the two in there, and this looks just like that intermediate code that we produced over here, right? But then we go on to step number 3, and what's special about a macro is that it's going to hit this expression with an extra evaluation. So under the hood, this expression, again, this is grayed out because you don't see it happen, but it is happening. It's going to evaluate it in extra time and spit out that 4 that we wanted in the first place. Okay, so we see that we've skipped this annoying extra step. I call f of 2 and I immediately get the value I want. It's a little less explicit about what is happening. Um, and so it's annoying. It's cool because it's more convenient, but it's annoying because it's not as explicit about what it's doing. So that just means you have to understand the concept in your head. You won't be able to visually see what's going on. So we can make the claim that evaluating a macro procedure is approximately equal to evaluating a normal procedure, but then calling eval on it once again. But notes, yeah, I say approximately equal because again, there are other important properties of the macro. For example, the unevaluated operands, right? And why is that important? So here, I didn't really even need a macro. I could have just done my sort of, homemade macro over here. Um, but that's not always the case. So, for example, consider a case where the operand was not just a number, but actually an expression. like print X. If I called a procedure on print X in a normal function, well, when I call the function, it's going to evaluate the operand, right? So it's going to end up printing X before I even enter the function. So any argument that has a side effect when evaluated, it's going to get messy with a normal procedure. But macros are cool because they leave the operands untouched so that I can construct them and maneuver them however I want and ultimately construct my uh, expression. Okay. And then this is a very important conceptual question. So take a moment to think about this. Look at this macro, right? It has a quasi quotation. Think about the macro questions you've written. They have quasi quotation. What is the purpose of the quasi quote? What purpose does it serve in the broader context of our goal? Is it to keep the expression unevaluated so we can save it later for that evaluation? Uh, no. The quasi quote is there to make a list. We learned that quote parentheses makes the list. That's all we're doing. Okay. And then here I want to drive home a point that macro questions are not about quasi quotation. Macro questions are about constructing a list because lists are how we represent data in Scheme. And ultimately, our goal is to write our programs out of our data. So macros are here to construct lists, and that's all. And to prove that point, right, I didn't even need quasi quotation. I could have just used the list. Why does quasi quotation come up a lot of times? Because it's the easiest way to do things, right? I don't have to call a million conses. I can just have a quote and then we're done. Okay. So it's important to have that big picture in your head. Okay. So let's look at some examples. Let's first look at let's first try to implement OR. Okay. So OR is a procedure that you used in Scheme. Can you implement it yourself, obviously, without using OR? And then I wrote this question to help you solve discussion number 3. So sort of observe the solution to this and try to map it onto number 3, discussion 11 or 12. Okay. So here we go. Can you implement OR? Let's call it my OR. Okay. And so we've done enough theory. Now we're going to talk practical and implementation. How can we mechanically get through our macro problems? And I'm going to break this down to 3 steps. The first step is that, so first of all, what kind of questions do you get when someone asks you a question? Usually they're asking you something very obscure, like, hey, can you implement this switch that we see in Python and other languages? Can you implement it in Scheme, right? They're asking you, can you implement some new procedure, some new special form that doesn't exist using existing constructs of a language, right? So these are conceptually very tough questions, but and so that means that every time we start with a macro question, you have to think about what is the behavior of the construct they're asking me to build, right? If they're asking me to build switch, what does switch do? How does switch act on its operands? And how can I emulate that behavior using other things? How does the OR procedure work? And how can I emulate that behavior with other things that are not OR? So these are things that you're very used to using, but now we have to think critically about how they work. So when I call OR on some operands like 0, 1, and 2, what is actually happening? I'm going to look at every single operand. I'm going to say, are you true? If you're true, I'm going to return you. Okay. I'm going to look at the operand. Are you true? You're not. So I have to keep looking. Are you true? You are true. So I'm going to return you. Okay. I'm going to look at you. Are you true? You are not true. I'm going to look at the next one. You're false. I'm going to look at the next one. And since everyone is false, I'm going to return false. Okay. So the behavior is that we want to evaluate each item and return the item if it's true, else return false if everyone is false. And then, so now we want to think about, imagine OR is some novel behavior that doesn't exist in our language. Now, what existing behaviors in our language can I use to build this new behavior, right? Um, what what were we doing? We were saying if this, return this, elif this, return this, elif this, return this, else return false. Oh, isn't that just a chain of if else's, right? So what does that mean? I'm going to use the if control structure to build my OR because I'm not allowed to use OR. Again, imagine we're trying to event the OR, okay? Um, So here we go. I want you to define macro. I'm gonna call it my or, and it takes in expressions, which is a list of operands. And yeah, right. Like, how does or actually work? It's really just a series of if statements. I'm gonna say if first operand is true, return it. Else, if it's false, I'm gonna check the next operand. Are you true? If you're true, return it. Else, check the next operand. Else, return false. This is the code under the hood that actually implements our desired behavior. And step one to writing a macro question is identifying the code that achieves that behavior. Um, and then, yeah, once we know the behavior, we want to actually implement that behavior. So we want to implement the logic to capture that behavior. Um, and then, so now I'm going to make a couple of syntactical shortcuts. In Python, I don't need to say if this is true, return it. I can just say if the thing, right? Because that thing will inherently evaluate the truth or falsity. So I can just say if thing, return thing, else if thing, return thing. Let's condense it. Let's use cond. Let's uh, shorten it. So now we have this. And then step three is I now know, okay, so we started off with identifying what behavior we want. And then step two was writing the code that implements the behavior. And step three is writing the code that would produce the code that would produce our behavior. Okay. So in the yellow box is the code that when you execute would produce the behavior we want, right? The macro is the code that would produce this code. Okay. So this code, let me write it out all on one line. It's simply a list because like I said, everything in Scheme is a list. So to write the macro, I need to write a function that produces this list. Okay. So this is a physical list. This is data, and all data in Scheme is a list. So I need to now construct this list. So take a moment, think. Using the tools like cons list, append, and so on, how can I construct this list? And this is not a macro question. This is something that you should be able to answer based on knowledge you learned in the first week of Scheme. Okay. So let's first tackle this middle set of pairs. Okay. And the complexity here is that there might be an arbitrary number of operands, right? Not just be 0, 1, 2. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8. And to accommodate for that dynamic length, let's use map. Okay. So for every single expression in expressions, for every single expression X in expressions, I'm going to map it onto the list that has X and X, right? So for this operand 0, I want to transform it into a list that contains 0 and 0. For this operand 1, I want to transform it into a list of 1 and 1. And that is what this mapping function does. And this allows us to map it onto an arbitrary length expressions. Okay. And then let's do the else false part. And I notice this also has to be in its own list. So what I'm going to do is I'm going to take this expression and I'm going to append a list of a list onto it. Okay. And since appending is like extend, that's going to destroy the outer list, right? So better have an inner list so that I still maintain the nesting. And then finally, to build this list, I know I need cond at the start. And to add something at the start that isn't nested, I can just cond. Okay. And if you execute this code, you will produce this list. And this list is this code. And if you evaluate this code, you get the behavior we want. And this code right here is our macro. Okay. So this code right here that implements our behavior is simply the program. Okay. This is not the macro. Um, and then this right here is the data that would produce that program. And this is the macro. Okay. Um, so yeah, there we are. That's the big picture, right? Going back to the start of the video, we are no longer writing functions that just produce a number or a list. We are writing functions that when you call it, it will produce more code. And then that code, when you evaluate it, produces the actual value. So this is the code that when you call it, is going to produce more code, which is this orange code. And the orange code, once you evaluate it, is how you get the actual 0. And that is the story of macros. So there we go. We have completed our macro. And notice I did not need any quasi quotation. So big picture, we write macros. Macros produce the data that, when evaluated, produce the desired behavior. Um, Very quick aside, how do I prove my solution is right? Well, recall that the find macro is going to hit my evaluated expression with an extra valuation. So if I want to see that intermediate form that gets produced, like here, if I wanted to investigate this orange box, which, I mean, it would be very helpful to see this for debugging, right? But the macro sort of hides that from us. So what I can do is I can get rid of the macro and just make it a normal procedure. And then I have to quote all my operands, because to emulate a macro, I have to leave the operands unevaluated. So if I quote my operand like this on a what is no longer a macro procedure, but a normal procedure, I can sort of uncover that middle code that our macro is actually producing. All right. So as a summary of our steps with macros, the goal is to invent some new procedure. So I'm going to start by thinking about what is the desired behavior. And then step two is I want to implement the logic that will produce that behavior. And then finally, I want to write that implementation logic as a list, because the lists are our data in Scheme. Return that list and we're done. Here are some parting questions. Okay. Let's work on another one from discussion. This is multiple assignment. And yeah, this is a very good question. All right, this is one of my favorite questions, and it really helps you dig into how macros are working. Okay, so I want you to implement, once again, every time you see a macro question, you get these very obscure questions that ask you to invent some new behavior, and they're very weird, but that's what they're going to be. And so in Scheme, we can't or so here in Python, we can do this, right? I can say x comma y is equal to 2 comma 3, or I can say x comma y is equal to y comma x, and then that's going to flip the variables because these happen simultaneously. Um, yeah. Can we do the same thing in Scheme, right? So obviously in Scheme, I can define one thing to be one thing, but can I define two things to be two other things? So let's try to do that. Okay. So if I want to, and then so now okay, so obviously in the discussion you were given this skeleton, right? But let's take a step back. Let's say you weren't given that skeleton. Based on what we've talked about today, you should be able to write this macro from scratch, right? Because step one is thinking about the behavior. What is the behavior? The behavior is that I want to assign two things at once. Okay, so now I ask, what is the code that can implement that behavior? Well, I mean, I know how to assign things, right? I just use a define statement. And then how do I do two things? I can use a begin. So I can do begin, define, define, and then, oh, that is your macro, right? So we've sort of just derived where the skeleton comes from. Okay, starting from the behavior and then think about the logic that would implement the behavior. Okay, so I'm going to define sim1 to be expression1, and then I'm going to define, yeah, so this is what I just talked about. What novel behavior do we need to create and form many symbol value bindings at once? And then what existing structures in Scheme can help us create that behavior? Well, I mean, normally for one binding, I would use define. So why don't we just chain together a couple using begin? All right. So I'm sure most of you opened this discussion and you tried this. Okay. So you said, I'm going to define sim1 to be expression1. I'm going to define sim2 to be expression2. And you saw this was wrong and confused. So this is a naive solution. Let's understand why it's wrong. So I'm going to assign x and y to be 2 and 3. And then I'm going to swap x and y with y and x. Okay. So x should be 2 and y should be 3. And then let's swap them. Um, and then it says that x is 3 and y is 3. Oh no, so what happened? Let's investigate. Let's use our trick that I taught you before of getting rid of the define macro and just doing define. So we can investigate that internal code that gets evaluated. So again, I have to unevaluate my operands to emulate what macros do to operands. And then if I run this, I get this code. This is the code that is getting run by your macro. And think about what is the issue with this, because it looks right. I'm going to define x to be y and define y to be x. But the issue is that this happens sequentially, right? So if I define x to be y and then I define y to be x, well, x is already set for y, so now y is going to be bound to y, which makes no sense. Okay. So because these are happening sequentially and not simultaneously, we can't get simultaneous assignment. So how can we ever achieve simultaneous assignment instead of sequential assignment? The idea is that right now the value of x here is dependent on the value of x here, right? So the idea is, can we remove that reliance? And can we sort of stick it, can we tell this second defined statement that, hey, you should set y to this value? Or like, can we, so there's this dependency here. Can we eliminate that dependency? Can we just stick the two in here so that the second expression no longer has to rely on the first expression? That's the key idea, and this is the answer, as you've seen from discussion. Let's understand why this solution works. Okay, so I'm going to make a central claim throughout this part. This is a very important idea, and that is to evaluate something is to unquote something, and to unevaluate something is to quote something. Okay, so let's keep this dogma in mind. So this is a solution. Let's see why it works. Okay. So let's say someone calls a sign x by yx, where x is 2 and y is 3. So everyone's going to come in and recall that operands are not evaluated, and to unevaluate is to quote, so everyone gains a quote when they enter a macro procedure. Okay, these are going to flow into my function. I'm just plugging them in, okay? So I have comma sim1, I have comma quote x, and then what does comma quote x evaluate to? Well, a comma tells me to evaluate it, okay? And to evaluate is to unquote. So if I take a quote away from x, it will just be x, okay? So let's do some practice. If I tell you to evaluate quote, 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 x, to evaluate is to unquote, so I'll remove a quote to, and now if I do three quotes, it'll be two quotes. If I do two quotes, it'll be one quote. And if I finally evaluate quote x, it'll just be x. And if I evaluate x, you'll finally get the value. Okay, let's move on to the next line. Okay, so we have define xy just like we wanted. And then on the second line, I'm going to define sim2, which is comma quote y, and these are going to cancel each other out. So I'm defining y to be something. And I know this something better evaluate to my number, right? That's going to help us solve the question. Because if it was define xy and define yx, then we'd run into issues. But if it's define y2, then everything will work out beautifully. So let's see why eval is going to save the day for us. And so let's just first talk about some things I heard in class. Okay, so I heard that, okay, because we're calling eval, then scheme is going to, it's going to take precedence over here. So scheme is going to know to evaluate the x first, put in the two, and then we're good to go. That is one sort of reasoning I heard in class. Another reasoning is like, okay, well, the comma evaluates once, and then the eval is going to evaluate twice, and that gets us the two. Both of those are close, but not exactly there. And the actual answer is very strange. So the reason it works is that so if I define x to be 3 and I evaluate quote x, I've been making the claim that to evaluate something is to take away a quote, right? So by that logic, eval on quote x should be x, but it's actually 3. And the reason is back to the first week of class. When I evaluate a procedure like eval, I'm going to first evaluate the operand, which evaluates to eval, and then I'm going to evaluate the operand. And this is our first evaluation. So notice here that because, so quote x evaluates to 3, which means that two evaluations happen. And that's because the first evaluation happens inherently as a byproduct of the language evaluating the operand, right? And then the second evaluation happens because I'm applying the eval procedure. So the result is that I've evaluated my operand twice. So quote x isn't going to evaluate to x, but it's going to evaluate to 3. Okay, so the conclusion is that eval on an operand evaluates the operand twice. And that is what gets us the number embedded in my expression. Okay, and why did it evaluate twice? Was it because I call eval once and I call comma twice? Well, no, comma also evaluates, right? So it's not the or so another sort of argument I heard in class is that, everyone else isn't evaluated. So we have to physically evaluate this one. No, comma is evaluating. So why do I need an extra eval here? Because its eval has this funky behavior where it evaluates its operand twice. And we need that behavior here to get the quote x into its actual value too. Okay? So it's not that the comma evaluates one and then eval evaluates once and they all together evaluate twice. It's more so that the comma is going to kick off the evaluation of this expression. And then when you evaluate this expression, when you call eval on any operand, we will evaluate it twice. Okay, so now that you understand that logic, or if you internalize that logic, the challenge should be very simple, right? So the challenge is, can you do multiple assignment, but now for sort of quoted like letters, right? So instead of defining z to be a number, can I define it to a character being x? And in order to do that, I have to quote it, right? Because if I define z to be x, it's going to error because it's not going to know what x is. Okay, so let's define v to be 2 and w to be z, which is bound to the symbol x. Let's look at our current solution and let's look at why it breaks down. So I'm going to insert everyone into my function. I have my v, my w, my 2, and my z. As we all know, operands are not evaluated, so they're going to gain a quote. I'm going to plug these into my code, and then the comma and the quote are going to cancel each other out. And then here, this is going to cancel each other out. And then let's do comma quote z. What is that? Or comma eval quote z. Well, I know eval is going to take away two quotes, which gets us the x. Okay? So I'm going to define w to be x, and then this actually errors. Do you see why? Well, it's because it's going to try to define w to be x, but does not have a quote. So it's going to scheme is going to ask, what is x set to? Right. So we were trying to bind z to the actual symbol x, but instead it's trying to set it to a variable x, and there is no variable set to x in the current environment. So this is going to error. So we have to. So do you see what the answer is? The answer is simply that I have to guard this guy with an extra quote and tell Scheme, no, 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 this is a symbol. Please don't evaluate it. So the answer is simply that we need to add a quote and we're done. And you've done the challenge, right? Okay. So let's go back and just do a couple more examples to nail the concept down. So here's a first example. This is called apply twice. Let's say I want you to write a macro. I want you to create a special form that that will call a procedure on its operand twice. Okay, so if I have a procedure called add one that adds one to a number, and I call it on three, uh, what it should do is it should call add one on three twice for an output of five. Okay, so let's define a function called add one. Uh, it adds one to a number. And then if I call, sorry, this is just an arbitrary function. This is my actual macro. It's called apply twice. If I call my macro on add one of one, it's going to output three because it has called add one on one twice. Okay, confusing concept, but I want you to write a special form that applies a procedure twice onto its operand. Okay, and that is the goal. And then you just have to get used to sort of answering these very abstract questions because you're inventing things that don't exist, which is why macros feel very weird. So what is the macro? What is the code that we have to write? Okay, let's go through our steps. All right. So we have to envision the transformation that we want to make to our code, right? So if our input is add one, polygon three, then the output that I want is I want add one of three, right? I want to nest add one within itself. So if we need to add one twice, then I need to call add one again on the result of add one. So let's physically construct the code that would do that, right? So if this is my input, the output that I want to transform myself into is add one of three, okay? So again, this is that intermediate code that is going to get evaluated. And then the macro is the code that produces this code. Okay, so this is the behavior that I want to achieve, and then your goal is to write the code that would produce the code that produces the behavior we want. Okay, so how do I transform into this? Using elements of this, how do I become this? Um, okay, so how can I do that? If this is a list and I want to make this list, all I have to do is cons add one onto cons add one of three, right? Do we see how if you execute and make this list, you get this list? And why are we making lists? Because our data in scheme, everything is a list. Okay, I'm physically making this list out. So let's substitute in the actual the names now. So instead of the example, I'm going to actually substitute in uh, the car of call expression, right? If this is if this is the entire call expression, then I want to cons the car of it, which is add one, and I want to cons it onto cons call of expression onto nil, so I get the nested list. There's different ways you could have written this. I could have cons car of call expression onto list of call expression. That also works. Okay. Um, and there we go. We've written our macro. Okay. So I take my input, I transform it into some expression, and then your macro is the code that represents your transform expression as a list. And this is an alternative. There's a billion different ways you could have written this. You could have done this with quasi quotation. You could have done this with cons par call expression onto list of call expression. Okay, so a billion different ways to make a list, as you know. Final example, the max procedure doesn't exist in Scheme, right? So let's invent it. Let's do it. So if I have two expressions and I want to take the max of the expression, so this is going to evaluate to 1 and this is going to evaluate to 7, then the max should be 7, right? So let's define a macro that will take the max of two expressions. Um, so we think. So again, we start with the behavior. When you execute maps on two inputs, what are you doing to produce that behavior? Well, what you're doing is you're looking at the first value and comparing it to the second value. If the first value is greater than the second value, then I want to return it. Else, I'm going to return the second value. Oh, wait, doesn't that feel like an if else, right? So the control structure that I'm going to use to emulate a max is simply if else, okay? So I'm going to say if my first expression is greater than my second expression, then return it, else return the other one. And that's it. This is the code that produces the behavior we want. And finally, the macro is the code that produces this code. The macro is the code that represents this as a list. Okay? So, sorry. I'm going to take this. I'm going to unindent everything so it's a long list. And then I'm going to substitute in the actual like variable names. And then I'm going to make it into a scheme list. I'm going to write the code that produces this list, and this is my macro, and we are done. Okay, so this is sort of an algorithm to write your macro questions. You start with your expressions, then you think about how do I want to transform them to produce my desired output. This is the code that's going to produce that output. And then all we have to do is think of this code as a list. And then your macro is the code that writes this as a list. Okay. I'm going to turn this into a list and I'm going to write some code to make that list. And you are done.